A robot with the body of an ordinary person has just run like an Olympic champion, not in a controlled laboratory, not in a simulation, on an athletics track, outdoors, under the gaze of researchers and cameras. The speed recorded on the meter was 10.1 meters per second, the equivalent of finishing the 100 meters flat in 10 seconds. And the deadline to surpass Usain Bolt? Mid-2026. That is just a few months away. What you are about to discover is already being discussed by robotics specialists around the world, and it completely changes what we thought we knew about the limits of machines. Want to understand everything? Then watch the video until the end and I will explain. But first, leave your like and subscribe to the channel. That way you will stay informed about the latest news in robotics. On an athletics track, somewhere in China, a humanoid robot burst into a sprint. As it crossed the speed meter installed on the track, the display recorded 10.1 meters per second. The scene was filmed, published on YouTube by Unitree Robotics, and quickly accumulated more than 270,000 views on the platform X. The world of robotics stopped to watch. The robot in question is the H1 model, developed by Unitree Robotics, a company headquartered in Hangzhou, China. The company announced that the performance represents a new world record for humanoid robots, that is, robots with a shape and movements inspired by the human body. To make the weight of that number clear, 10 meters per second is equivalent to covering the 100 meters flat in exactly 10 seconds. For comparison, Usain Bolt set the current human world record at 9.58 seconds in 2009, which equates to an average speed of 10.44 meters per second. The company itself acknowledged that the meter may have presented a margin of error, but even with that caveat, what the video shows is undeniable. The robot runs with a fluidity of movement that, until recently, would have been difficult to imagine for a machine. What is surprising is not just the speed, but how well the system already works as a whole. The way it perceives the environment, acts, and makes decisions learned in practice. The robot has measurements close to those of an ordinary human being. It weighs approximately 62 kilograms, compatible with an average-built adult person, and has a total leg length of 0.8 meters. Unitree itself used this as a marketing argument, with the caption in the video, "With the physique of an ordinary person, running at the speed of a world champion." The phrase is not just advertising, it encapsulates what makes this achievement technically remarkable. The robot was not built with unrealistic dimensions or weights. It replicates human proportions and still reaches speeds that very few human beings attain. The context of this news is as important as the numbers. Wang Xingxing, founder and chief executive of Unitree, declared at the Yabuli Entrepreneurs Forum, one of the most influential business gatherings in China, that Chinese humanoid robots will break the 10-second barrier in the 100 meters flat by the end of 2026. That is, surpass Usain Bolt. The statement sounded bold when it was made, in March of this year. Now, with the robot already at the 10 meters per second mark, the deadline seems less fantastical than it did a few weeks ago. Unitree announced this week plans to globally launch its most affordable model, a humanoid robot for $4,000, sold through AliExpress, with a focus on markets in North America, Europe, Japan, and Singapore. Physical speed and accessible price. The company is playing on two fronts at the same time. And the question that specialists are beginning to ask more frequently is, how much time remains before humanoid robots leave laboratories and athletics tracks to occupy spaces that today are exclusively human? To understand why this record is significant, it is worth looking at the recent history of the robot itself. In March 2024, just over a year ago, a previous version of the same robot entered the Guinness records as the fastest full-size humanoid in the world. The speed recorded at that moment? 3.3 meters per second. That was equivalent to a brisk walk, just over 11 kilometers per hour. The previous record belonged to the Atlas robot from Boston Dynamics with 2.5 meters per second. The leap from 3.3 to 10 meters per second in just over a year represents an increase of more than 200% in the maximum recorded speed. It is a pace of evolution that surprised even specialists accustomed to the sector. Those who have already worked with this robot know how technically impressive this achievement is. The great advance came mainly from improvements in the software and in the way the system is controlled, not just in the hardware. And here lies a fundamental detail. The robot that ran on the track did not receive a radical redesign of its structure. It is essentially the same body, with updates to the control system, the set of algorithms that translates movement intentions into commands sent to the motors of the joints. To put it simply, the robot became faster because it learned to move better, not because it was built from scratch. The robot is equipped with a propulsion system developed by Unitree itself, a powertrain with proprietary gears and high-torque motors developed in-house. Torque, in this context, is the rotational force that the motors apply to the joints. The greater it is, the more power for fast movements and the greater the capacity to maintain balance in dynamic situations. The robot also has a depth camera and a sensor that uses laser pulses to map the environment in 3 dimensions, giving it the ability to perceive obstacles and surfaces in real time. Each leg has 5 degrees of freedom, that is, 5 joints that move independently, and each arm has 4. This is what allows the robot to maintain dynamic balance while running. The coordination between these multiple joints is controlled in real time by a computing system embedded in the robot itself. The battery has a capacity of 0.863 kilowatt-hours and an autonomy compatible with field tasks. What has changed compared to what existed before is not just the speed, it is the stability at that speed. Previous videos showed the robot maintaining its balance even when kicked during walking. The current version goes further. It maintains posture and running rhythm at a level that approaches human athletic standards. This is relevant because, in field robotics, that is, robots that need to operate in real, uncontrolled environments, the ability to recover from disturbances is just as important as raw speed. In addition to the current model, it is worth mentioning that Unitree is developing a more sophisticated model with 31 degrees of freedom, compared to 9 for the current model per limb. This new model trades maximum speed for greater humanoid dexterity. It currently has a running speed of less than 2 meters per second, but is capable of much more detailed movements with the hands and arms. These are two projects with distinct philosophies, the first as a raw performance platform, the second as a gestural intelligence and fine manipulation platform. What this record indicates goes far beyond a race on an athletics track. Fast and stable humanoid robots are natural candidates for functions in logistics, high-speed manufacturing, search and rescue operations, and military environments. Every leap in physical mobility brings these machines closer to the minimum requirements for replacing human workers in tasks that demand agile movement, such as loading, inspection, and patrolling. Unitree already sells humanoid robots to companies at prices as low as $16,000 and is studying producing 75,000 units per year in a new factory. When speed and cost intersect, the equation changes for entire sectors, and professions that depend on physical mobility begin to enter the radar of this transformation. On the other hand, the advance opens up real possibilities in areas where speed is a matter of life or death. Emergency response, firefighting, exploration of contaminated environments. A robot that runs at 10 meters per second can reach risk zones before any human team without putting lives in danger. The debate that specialists are now engaged in is no longer about if humanoids will be useful, but when. And the result achieved by this robot suggests that moment is closer than most people imagine. The record did not arrive in a vacuum. It arrived at a precise moment in Unitree's trajectory, and that matters. In March 2026, the company filed a request to go public on the Shanghai Stock Exchange, aiming to raise 4.2 billion yuan, equivalent to approximately $610 million. According to data from the offering prospectus, Unitree was the company that sold the most humanoid robots in the world in 2025, with more than 5,500 units delivered. Its revenue jumped 335% compared to the previous year, reaching 1.71 billion yuan. And for the first time, the company recorded a profit of 600 million yuan. In a sector where most competitors are still burning through cash with no forecast of profit, these numbers are a notable exception. Demonstrating a speed record at precisely this moment serves a dual function. It signals technical leadership to the market and sends a clear message to investors that Unitree does not just manufacture impressive prototypes, but machines that continually evolve. Analysts highlighted that there are more than 100 humanoid robotics companies in China today, and that consolidation of the sector is coming. Whoever manages to combine scale, price, and performance will stay ahead. But what differentiates this robot from its closest competitors? The comparison is instructive. The Tesla Optimus, perhaps the most talked about humanoid robot outside China, recently reached a speed of approximately 2.7 meters per second in internal tests. The RobotEra STAR1 demonstrated speeds of 3.6 meters per second. In all these comparisons, the robot with 10 meters per second is in a completely different category of locomotion performance. The most relevant comparison is with MirrorMe, a Chinese company that launched its humanoid robot called Bolt in February 2026, a name that already reveals the intention. That robot stands 1.75 meters tall, weighs 75 kilograms, and also reaches 10 meters per second at peak speed. In other words, the Unitree robot did not surpass an international competitor on unfamiliar ground. It drew level with a domestic rival that had just set the mark. The dispute for the title of fastest humanoid robot at this moment is taking place between Chinese companies. This has a geopolitical dimension that specialists do not ignore. Researchers in the sector point out that China combines massive state investment, an integrated industrial supply chain, and a culture of rapid product iteration, characteristics that favor accelerated advances in robotic hardware. The second edition of the Humanoid Robot Half Marathon is being held in Beijing on April 19, 2026, with more than 300 robots registered. In the first edition, in April 2025, the robot developed by a research center linked to the Chinese state won the 100 meters in 21.5 seconds and completed the half marathon in approximately 2 hours and 40 minutes. These are already regular events. There is already a culture of competition, and the numbers keep falling. There are, however, important caveats. Running fast for a few meters is different from sustaining that performance in a real and prolonged task. Critics point out that humanoid robots, including the Unitree model, still fail frequently outside controlled environments when they encounter unexpected obstacles, uneven floors, or climate variations. Furthermore, the rules regarding the safety of robots in public spaces are still unclear in almost every country. And in a broader scenario, the rapid advance of robotics reignites the debate about the future of work, which functions will be automated, when that will happen, and what the impacts will be for workers, especially those on lower incomes. What this robot did on an athletics track is not just a technical record, it is a marker of an era. In 12 months, the maximum speed of humanoid robots went from 3.3 to 10 meters per second. This is not gradual evolution. It is a compression of time. What took decades in aviation or computing seems to be happening in months in locomotion robotics. And the trajectory does not suggest any slowdown. The question that remains is this. If a robot with the weight and proportions of an ordinary human being already runs at the speed of an elite athlete, what will be the next limit to disappear? And who or what will have to learn to live with that? Leave your answer in the comments. If you enjoyed the video, leave your like and subscribe to the channel. That way you will always receive notifications of new videos. Until next time.